Okay, thank you everybody for your patience. We'll now move on with Ricardo Martin Rodriguez.
Hi everyone, thank you for having me today. It is a pleasure to be here, even more considering this is a special edition of Hacktivity. My name is Ricardo, and today I will be unveiling an application I called Formshaker. And this is a project I started back in 2018, and the bulk of it was developed during the first few years. And since then, my friend Juan Manuel and I try to meet every now and then to work sporadically on adding new features or for bug fixing. So this is me on the left-hand side. You can find me in LinkedIn or Twitter. And on the left-hand side is Juan Manuel, who is an offensive security engineer, and you can find him on LinkedIn. So this is the agenda for this presentation. First, I'm going to talk about the problem, how we came up with this idea, how we solved it. Then I'll explain what Formshaker is. Then some basic concepts on which the application relies to function, as well as break down the EAS, break down the EAS agent. I'll show you some demos if time's allowed it. Then I'll talk briefly about some components the application is made up, as well as some aspects we'd like to improve in the future. And then to wrap up, conclusion. So the problem. So usually when we find an XSS, we try to follow some potential path. One of them is stealing the session cookies when they are available. That's because the HTTP-only protection is not protecting that cookie. Another path is to trick a victim into writing his credentials. You can write a ES payload that will pop up a window, so the user is asked to write his credentials, and then we collect them, send them to a location under our control. Another path is to redirect a victim to another website to run an exploit, or to download a malware to compromise his computer. And then there is another path, which is accessing the available functionality on the website. This is a path people don't generally pay attention to this path, don't take the seriousness of it. And I believe there is no tool to make the most of the HTML forms available on the website. So now I want you to imagine you found an XSS and also have identified a very interesting form on the website. So you start writing a ES payload to submit that form, basically. And you have to keep in mind certain things. For example, the form input, the input requirements, as well as the encoding for the form data, which can be multi-part form or XURL encoded. On top of that, you have to keep in mind that the form might be protected against CSRF attacks, meaning you have to write the logic to extract that token, that CSRF token, and include it in the subsequent request. So this is one option. Another option is one that requires a more manual approach. It's a two-stage attack, where the first stage consists of writing a EAS payload for the XSS, and the EAS payload will basically extract the CSRF token and send it back to us. So then we can deliver the second stage, which is basically a CSRF attack. We prepare an HTML form, we supply the data that's convenient for us, and we include that CSRF obtained in the first stage. The problem is, by the time you deliver the second stage, the CSRF token might become invalid, either because the user logged out or because the session expired. If that wasn't enough, you have to keep in mind that since 2020, Google Chrome implemented the lax mode for the same-side cookie protection. So this scenario becomes even more difficult to deliver. Then another thing you have to keep in mind is that not all the functionality available in the website is visible and accessible for your user. And that's because you have been given some permissions or some role on the website, and users with higher privileges, for example, the admin, may have access to other functionality, for example, for user creation. So in this talk, we're going to explore these scenarios and how we can leverage Formshaker to make the most of them. So Formshaker, first of all, consists of a JavaScript library that from now on I will refer to it as the EAS agent, and also a web application. Formshaker is a tool that exposes a website to perform further exploitation after an XSS is found, and it's a tool that gives you control and access over the HTML forms available on a website. It's an offensive tool for assisting red teams and hacking exercise. So basically, the EAS agent acts more or less like a proxy between the victim's browser and the attacker. So once the EAS agent is running on the victim's browser, its main goal is to execute unwanted actions on the vulnerable website in the victim's context. And you, as an attacker, you can leverage Formshaker to submit the forms present on that website. So now you might think, isn't there a tool to do what you claim Formshaker does? Well, let me say I couldn't find anything. It doesn't mean it doesn't exist. In fact, if you are familiar with a similar solution, after the talk, please let me know. And there are a number of tools to exploit XSS, and there are even more tools to provide more capabilities to an attacker once an XSS is found. Just as Formshaker or BIF, right? So now let's break down the EAS agent process. So we are going to break it down in smaller pieces. There are three main processes: the crawling process, the form harvesting, and the form submission, in this order. And these are the processes happening behind the scene while the EAS agent runs on a browser. So the EAS agent offers two modes to run these three processes. One mode is using iframes, and the other mode is using IAS request. But before digging into these three processes, let's start by talking about some basic concepts, such as web scraping, crawling, CORS, and iframe policy. So for those who are not familiar with web scraping, this term refers to the process of extracting certain information from websites, such as HTML elements. You parse the HTML and you extract links, for example. Then with those links, you crawl those links, which is the definition of crawling. Crawling means visiting parts of the website using the link collecting during the previous phase, during the web scraping. It's like one process feeds the other. You visit one website, you collect the links, and visit them. Once you visit them, you, again, will scrap the website, web page, and obtain more links. The idea is to explore the website. So before continuing on, it's crucial that I mention that the EAS agent runs these two processes. To explore the website, using either iframes or AJAX requests. Now, CORS. Let me say that this slide is specifically here to explain a protection I have to keep in mind while writing the code to run the three processes using IAS requests. And for those who are not familiar with CORS, it stands for cross-origin request sharing, and it's basically a mechanism used by web browsers to allow web applications running in one domain to request resources such as data or assets from another domain. Now let's focus on the first example, the example above. So there is a JS library running on domain1.com requesting resources from the same domain, like /a/b, and there is nothing wrong with that. This is a common behavior we see everywhere. Then the other example below, there is one JS library running domain1.com that, apart from requesting resources from the same domain, is also trying to request resources from domain2.com, such as domain2.com/a and b. And unless domain2.com doesn't respond with the right headers, that communication won't happen. The response won't return to the EAS agent. And in fact, if you are in front of the browser, you receive an error. The browser will trigger an exception or display an error, such as this one. Access to fetch destination domain2.com/a from origin domain1.com has been blocked by CORS. So the takeaway in this slide is that the EAS agent using IAS requests to crawl the website works like in the first example, example above, and doesn't conflict with the CORS mechanism. So now if you want to learn more about CORS, there are plenty of resources out there, but for this presentation, this is enough. Okay, now let's talk about iframes. Similarly, I had to keep in mind that these protections, iframe protections, when writing the code for running the three processes using iframes. These two protections, X-frames option and CSP, and more specifically, frames ancestor, are protections to prevent or protect against clickjacking attacks. X-frame options being available for a long time now, whereas content security policy is newer and give you more flexibility when it comes to prevent client-side attacks. But both specify valid parents that might be embedded in a page using frame, iframe, object, embed, or applet. So, this is an example. This is an example of the CSP header with the frames ancestor directive, and this is how it works. Let's say Google.com responds with that header. This means that you can create an iframe, just like the one on the right, pointing to Google.com. There's nothing wrong with that, but if you try to do the same pointing to YouTube.com, it will be a conflict, and you will receive an error. So based on my experience, most websites are configured to allow the use of iframes as long as those iframes load some content from the same website. Okay? Just like in here with the self. Since the ES agent creates iframes to crawl the website, the same website when it is running, this protection will not prevent the ES agent from running. That's the whole point. So now let's talk about the first of the three processes. So the crawling process is a process responsible for web scraping and crawling the entire website. The ES agent offers two modes. You can crawl the website using either AJAX request or iframe. When using AJAX request, the process is very fast. It transmits session cookies and relies on XML HTTP request JavaScript object. On the left-hand side, you can see a screenshot from a network traffic capture, and that highlighted header, request header, denotes that that request was originated through the AJAX mode for crawling the website. So then we have the iframe base, which is slower than the AJAX base, work with session cookies and also is able to send basic authentication. And this mode relies on a custom multi-iframe implementation I wrote, which let you use up to 6 iframes to visit different parts of the web page. So before continuing on, let me say that in both cases we use DOM, which is the standard for accessing HTML documents, to parse the HTML elements and obtain the links of the visited pages. So now I'll show you an example that will be illustrative of the iframe mode for crawling a website. All right, so in this case, whilst the Formshaker JS agent runs on a web page, like in this example, google.com, it creates 6 iframes to crawl the website. In the first, as you can see there are 6 iframes. And the first iframe, it will load /admin, the second /profile, third /application, the fourth /user, and so on until the limit for the crawl maximum depth is reached. All right, so now let's talk about the second of the 3 processes, the form harvesting. And this refers to the process of gathering or collecting the HTML form present on the website as it's crawled, all right? Again, the ES agent offers 2 modes to harvest the forms using iframes or using AJAX requests. So using iframes, it relies on the outer HTML element attribute of the element DOM interface, and through this attribute, we can access and retrieve HTML elements dynamically rendered, such as dynamically rendered forms. Okay, and this is an advantage over the AJAX base, which relies only on the raw HTTP response. On the left-hand side, you can see a JSON object with the properties of one of the HTML HTML forms harvested throughout this process. Now let's talk about the third and the last of the three processes, and it's the process on which the JS agent submits the HTML forms. Injecting process is the way I call it to distinguish a regular form submission through a browser from a form submitted through the JS agent. Hope this is clear. Anyway, I'll show you some example. So again, for injecting or submitting forms, you can use Ajax requests or iframes. When using Ajax requests, the process is going to be very fast. It's able to work with session cookies. It's able to send the CSRF token via post or get parameters. And again, on the right-hand side, you can see a screenshot from a network traffic capture. And that header denotes that that request was originated through the Ajax mode while trying to submit a form. Regarding the iframe base, it's slower than the Ajax base, and it's able to work with session cookies. It's able to send the CSRF token via post or get parameter. And in addition, it's able to send the CSRF token via headers, work with basic authentication, and if the form data is sent in JSON format, it will send it anyway. The last thing is that through the iframe base, you can inject or submit the forms dynamically rendered. So next, I'll show you another example that will be illustrative of the iframe mode for injecting process. All right, this example of injecting a form through the iframe mode. So let's say providing this payload or JSON object, on the one on the left-hand side, to the JS agent, it will be able to create an iframe, just like the one on the right-hand side screenshot, locates inside the iframe the target HTML form, and then fill out the inputs with the data we supply. And lastly, the form will be submitted automatically. So let me say that the process conducted using the iframe mode are completely invisible. I just made them visible for the sake of presentation, so everyone can see and understand the process more clearly. But yeah, in a real scenario, you wouldn't see the child iframe you see there. So now let's talk briefly about the components, the two main components. On one hand, we have the JS agent, which is a vanilla JavaScript application. And on the other hand, we have the web application, which is made up of three elements: an API written in Python, a dashboard in React.js, and it incorporates a MongoDB, which will store the collected forms object, among other things. So now I will talk briefly about some of the dashboard features. So the dashboard implements WebSockets to display the incoming forms in real time. From there, you can view and fill out HTML forms and then push them to the injecting queue. Dashboard also offers a JS agent builder, where you can select among these two modes I explained before, iframes or Ajax requests, or you can select use the default mode, which is using both iframes and Ajax. It has proven to be more effective and give you better results. Through the JS agent builder, you can also define the API URL, define the crawl maximum depth, and select if you want to minify or obfuscate the code. Then some cool features in the dashboard are the input patterns, which is a feature that consists of a list of entries on which each entry is made up of a regular expression and a value. For example, a regular expression like /email/I, and a value which can be your email address. So this will instruct the JS agent to work like this. So if the JS agent happen to, given this example I give you of an input pattern, so if the JS agent happen to come across a form which one of the inputs name matches that regular expression, it will replace the original value with your email address before that form is submitted automatically. But that's something else I'll explain in a bit. On the other hand, then we have seeds, which are another cool feature for the dashboard. And it's a list of entries that tells the JS agent to prioritize the crawling. So let's say you know for sure there is a route or path called /admin. So you can try to add that entry, and this tells the JS agent to crawl and harvest the forms in that path before the rest of the website. before crawling and harvesting the forms on the website. Then we have blacklist forms, which instructs the JS agent to avoid submitting certain forms, for example, those that include the word logout. An important thing to say is that the input patterns, the seed, and the blacklist settings will be embedded in the JS code, but can also be changed during the time execution. Then we have secret patterns that will basically instruct the dashboard. It will tell the dashboard, hey, if you come across an input which name matches one of the regular expressions in secret patterns, you should display in this view. For example, this is useful. For example, you can add an entry like API key, secret, password, and if among the forms sent to the dashboard, one of the inputs matches this regular expression, that the value will be displayed there. And lastly, through the dashboard, you can enable or disable the inject as it goes, which is a version I want to explain in a bit. We call it inject as it goes because it will submit all forms available on the website, or the standalone version. And so, as I said, there are two versions. For the JS agent, the web application dependent version, and the standalone or inject as it goes, which is useful for blind XSS. So the first one, the web application dependent version, refers to the workflow on which the JS agent talk or interact with the web application, whereas the standalone refers to the workflow on which there is no interaction with the web application. It's the so-called inject as it goes. So next, I'll show you a demo of both versions, how they work. Okay, so on the top right corner, I'm starting the Docker containers for the web application, for Formshaker web application. And on the top left corner, I'm starting the DVWA. For those who are not familiar with the DVWA, it's a web application vulnerable to a number of web vulnerabilities. Okay, it's a portal for training, it's an application for training, and that's pretty much it. So on the right-hand side, that's the Formshaker web application. And on the left-hand side is the DVWA portal. I'm just now setting up some things before logging. Now logging in. The first thing I show you is a form that is an unrestricted file uploader. As basically upload a basic sample as an image. That image will be saved or moved to this location, /hackable/upload. You can see that image there, nothing wrong with that. But now I will inject the JS payload through a form vulnerable to XSS. For that, I will generate the JS payload, JS agent. That will be located in /API/agent.js. And now I'll inject that payload, just like that. A script, SRS, and then point to the JS agent located in the API. So now, if everything goes as expected, as planned, we should start seeing the same forms on the DVWA portal, but this time on the Formshaker dashboard. There we go. So now I can look for the form that corresponds to the form we used before to upload that harmless image. But this time, instead of uploading an image, I'm uploading a PHP shell. I saved it, and before I inject it, I'll refresh that page, so you see that there is nothing apart from the image. And now I'm going to inject it. So once I reload that folder, you can see that the web shell, the PHP web shell, is uploaded. Just run a simple OS command to prove it. So now the next demo, in the next demo, I'll be using a form vulnerable to OS command injection. And in this form, you are supposed to type an IP address, because behind the scene, it will run a ping command. Apart from adding the IP address, we'll append a character, the semicolon, and the command ls. So if that works, we should see the ping output plus the list of files in the current directory. There we go. We can see the list of files. So now we will try the same using Formshaker. But this time, instead of injecting a heartless command, I will use a reverse shell using socat. Okay, and that reverse shell will connect back to us and to the TCP port 1337. I saved it. Remember that saving it doesn't mean injecting. I need to do that second step. So I'm just starting a listener in the TCP port 1337, and now I'm going to inject it. And we get the connection back. So basically, now we have access to the Docker container because we were able to inject the reverse shell through the dashboard, through the EAS agent. So now the next demo, I will showcase the next demo. The next demo I will showcase is the one corresponding to the JS, the standalone or inject as it goes version. So remember, this version will basically, once executed, will crawl the website, gather all forms on the website, and fill out all forms input with either random data or, well, actually, with random data and with the information in the input patterns, features I explained before. And then we'll submit all forms, except those in the blacklist forms feature. So I'm, again, starting the listener. And this time, I'll go to the input patterns view. OK, I'm going to update one of them. So this one, this entry in particular includes the regular expression IP, okay, which matches the input name for the form vulnerable to OS command injection. All right, I'm gonna save it. I'm gonna update it using the reverse shell I used for the previous demo. Saved it. And now turn on the standalone version. I know it's not intuitive at all, and that's something we need to change. So basically, I'm forced to take the new changes. And now I'll go back to the DBWA portal. I will force the DBWA portal to reload the EAS agent changes, basically, using the form vulnerable to XSS. So if that works, remember, it will crawl the website, gather all forms, and submit all forms on the website, including the one vulnerable to OS command injection. That request will include the reverse shell. And we get back access to the Docker container. So this version is useful for blind XSS, or yeah, basically. So now going back to the presentation, you would agree with me that the more attempts we make, the more chances we have. That works in general life. So basically, sorry. So basically, for every, oops, it's not there. I thought it was there. Okay. So when the iframe and Ajax mode are active at the same time, which is the default settings, it will make up to 4 attempts to submit the injecting form. This gives us more assurance for the server to successfully process the forms with the data we supply. And now just some cool features for the EAS agent. Through the EAS agent, using the Ajax mode, you can upload any type of files like images, even for forms requiring multi-part form data encoding. And we got rid of third-party dependencies, or at least the biggest ones. And now it has better compatibility, and before we used to use fetch, now we use XML HTTP request, and implements seeds to prioritize the crawling process, as explained before. It has a redundant link prevention, so rewrites URLs and that kind of URLs that include IDs. It will try to avoid to visit more than one. It has mutex, so no more than one instance of the EAS library is running at a time. And it offers two flavors, as I explained, iframe or Ajax request, Ajax mode. The repository includes a unit test to test some aspect of the EAS agent. For example, how the inputs are treated or transformed after the algorithm for treating inputs is processed. Then also, the EAS agent is a modulated library, so you can test the EAS agent components individually. It offers the standalone version I mentioned before, plus the 4 attempts per form set to be injected. All right, so next I'll show you some future features that we have in mind, and I believe people would appreciate. And of course, it will improve the tool significantly. So regarding the EAS agent, we would like to add a feature to temporarily suspend the page while the EAS agent is running. And this way, we maximize the time the user is in the page. Authenticate against the API. And another very interesting feature is the form whitelisting for the inject as it goes mode. So instead of submitting all forms on the website, it will only submit certain forms. For example, if we add the user creation words, it will only look for forms containing these words. I think you get the idea behind. The idea is to submit the form corresponding to user creation, so we can create a user on the portal, maybe with high privileges. Regarding the dashboard, add more options to control the collected forms, and be able to manage 2 attacks from different origins, ingesting data simultaneously. At this moment, you can only run one attack. And again, authenticate the EAS library in this side of the application. Regarding SPA or single page application, unfortunately, that doesn't work. It doesn't work with single page application. Formshaker doesn't work. This is something we might look into in the future, but for now, this is how it works. To wrap up, conclusion, we are releasing the tool in the coming days. We plan to release it on Monday. We need to remove some comments. Well, any feedback or recommendation to improve the tool is more than welcome. Thank you all for the attention.
Thanks, Ricardo.